today I'm going to talk with you a little bit about what it's like to run infrastructure for HashiCorp, and sort of the experience of doing so. And you're also going to get a look at our infrastructure that's undergirding a lot of the services that we run. So let's do it. Click. Yeah. I'm Paul Hinze. That's my title. That's my Twitter. And I just talked about who I was, so you know. So I'm starting this out with some flavor that I have some sort of overarching themes that I want to stick in your head first, so that you have them in the back of your head throughout as we start digging into the details here. So I've been thinking about this a lot lately. Software as narrative, and the process of constructing software as the process of discovering the details about a problem and its potential solutions. I think this is just a really great lens with which to look at software engineering in general, and I think it's really started me thinking about the idea that systems are stories, problems are stories. The groups of communities of humans around these systems are all just attempting to build stories together and get more consistent about stories. Another kind of angle that you can take this concept is that classic sort of distinction between a software engineer and a senior software engineer. The software engineer says, is this the way we should do this? And the senior software engineer says, are we even solving the right problem here? Should this system even exist? Those are the kinds of things I think are really valuable to keep in mind as we talk about some of this stuff. The other one I want to give you out front is one of my favorite things about sort of the ethos behind HashiCorp. So Hashi in Japanese means bridge. It also means chopsticks, but we take bridge. And as Jessica, from the manager of the Terraform Enterprise team, will tell you, chopsticks are just a bridge from food to your mouth. And so it all makes sense. So this is one of my favorite sort of core tenets of the way that we operate, which is it's very easy when you're in infrastructure tooling, when you're a vendor trying to help people solve problems in general, to say, first, forget everything you know about X. Accept all of my premises, and then you can start to reap the benefits of my solution. That's never been HashiCorp's MO. The sort of principles of the DAO of HashiCorp are, simple composable tools that provide a bridge from your current state into, a slightly better state. And I think that's so core to the way that we solve problems, and it's really been sort of key to our success. And you'll see it kind of play out in the stories that we tell here. So if you're going to understand the infrastructure behind our products, you have to understand how our products have evolved. Like thinking about software as a narrative, it's something that's always changing. The system is always improving. The system continues to react to failure and get stronger, hopefully. So this is what I want to walk through. Sort of I've been around for a while, so we can talk about all the products and how they fit in here. So in the beginning, there was Vagrant, and it was good. I think, Mitchell's in college. Mitchell has this open source project that gets wild success because he's solving such a key problem in a really elegant way. He spends 2 years sort of developing Vagrant, getting more interest in it, decides to found HashiCorp, the company, with Arman. Now, this is at this point, HashiCorp, when it was founded, just was sitting on an open source project. So, beginning of the next year, releases second open source project, Packer. Now, this is, again, just an open source, a company, yes, but a company that's sitting on a bunch of open source projects. And the same year, a couple months later, the first commercial product is out. Now we're a software company. Now people are paying us money to build software. And notably, this software is downloadable software. This is a plugin for Vagrant that you pay money for, and then you download it on your computer. So now we're a downloadable software company. And then, less than a year later, we also became a services company. So Vagrant Cloud was introduced with Vagrant 1.5 and sort of this big refactor to be able to share boxes in a very consistent way. And now we're also a SaaS company. So we have some downloadable software, some SaaS, still a very tiny, tiny shop. 2014 is such a great year because console also comes out this year. And Terraform comes out this year. So it's, we're playing out this vision that Mitchell and Armand had very early on. And that's one of the most incredible things to me about this company is the amount of technical vision that is applied to our overall arc by our founders is just, it's really inspiring. It's one of the things that makes me really happy to be here. So again, these are open source projects. We're building out this portfolio of open source projects. One of the benefits of open source projects is we require very little infrastructure. GitHub's got this down for us. We don't have to do anything. So we have one piece of downloadable software, one service. And so 2014, huge year, 2 big open source releases, and Atlas. We introduced Atlas. Now, Atlas is an application, or was, I should say, an application delivery pipeline. Now, what does that mean? I think Mitchell's, the first time I asked him, how are we going to make this a sustainable business? His metaphor was always, we're tool makers. We make tools, and the sort of root tools, if you're thinking about building a house, are always going to be free. So the hammer, the saw, the wood, you can always get those for free. But in a commercial relationship, people want things that are a little bit more stitched together. So when people want to come to us and just buy a house, that is, or sort of want a more mature relationship with us, that's where we kind of draw the line. And we have, as has been mentioned in the earlier keynotes, been developing this pretty robust framework as to how we decide what goes into enterprise products. But this time, 2014, our thesis statement was unify the open source projects. So the open source projects are these discrete pieces of an overall vision. And so maybe the best way to sort of upgrade to a commercial relationship with people is to stitch them all together. And so Atlas is an application delivery pipeline, a flagship SaaS. So this one's interesting. This was not in the original plan. Armand mentioned this in his opening keynote, right? HashiCorp Vault came out of original designs for Atlas, the need for secrets management, and through conversations with our customers, with our community members, ended up becoming a first-class project because people agreed that it was just so important and such an unsolved problem. Again, 2015, huge year. Nomad comes out this year too. Now we've kind of rounded out our open source product fleet, and again, from an infrastructure perspective, we're not adding much overhead. From a community perspective, plenty. Can I go back one? Double-clicked. We keep releasing these new projects, but that doesn't mean we were also iterating hard on Atlas throughout this time. So we were adding a ton of features to Atlas. At this point, it has a full sort of Packer and Terraform CI pipeline, as well as a bunch of console-related features as well. The lessons we're learning from our customers during this time is that they really didn't want an entire unified platform. That people really were invested in a subset of our products, and they wanted just kind of super versions of those products. Maybe 2 of them, maybe 3 of them, but not sort of an entire application delivery pipeline. It turns out, being modular and composable in the open source products, customers wanted that out of the enterprise products as well. So what we started to do is we took Atlas. Now, Atlas is actually the same SaaS that was Vagrant Cloud. So Vagrant Cloud sort of shifted. The infrastructure underneath it was the same thing that hosted Atlas. We'll get to see it in a second. And then so we took it and basically just defined it from a user interface perspective. So we said, same code base, same distributed system, same SaaS, but we're going to actually start calling out, these are the Packer features, the Terraform features, and the console features. We'll call them the enterprise respective products, but we'll keep the same application. And we got a lot more traction with this. Customers it made a lot more sense to customers. They could pick and choose what they purchased, and it worked really well. What didn't work well was delivery. So it turns out, I'm sure y'all have been in this situation where you start to try to deliver multiple products on the same platform, the same distributed system, where you start to have, so we had these different facets of our system, but it was all still one system. And it was a team trying to hack on the same distributed system. And so we started to have a lot of trouble just stepping on each other's toes. Specifically, the console features were a very interesting challenge for us because unlike Packer and Terraform, which are provision time operations, console's a runtime service. And so to provide sort of enterprise features like a nice UI and some alerting, we needed connections from customer console clusters up to our SaaS, which we had a pretty cool subsystem to do it, but it was very kind of tenuous. We had a lot of persistent TCP connections from customer console servers, which nobody from the infrastructure side was very happy about. So the time comes for Vault Enterprise. We want to deliver some enterprise functionality for Vault, and we said to ourselves, do we add this in to this distributed system that we're now sort of using this faceted approach? And based on the lessons we were learning, we decided, wait a second, can we just, we're really good at distributing Go binaries. Can we rethink the enterprise functionality we want to build in for Vault as just something we can build into a Go binary? And we lose all of the sort of distant connections required in the model we were using for console at the time. And so that's what we did. Vault Enterprise was announced. It was just a downloadable binary with some additional functionality. And that worked great. We used our existing build infrastructure with a couple of tweaks, and things were, from an infrastructure perspective, made much more sense to us and to our customers. This worked so well that we back applied it to console enterprise. So we took that sort of some of the functionality in the what was Atlas, and we rethought it as a downloadable binary, which is what it is today. And then this is all happening in 2016 and 2017. So over the course of the last year, you've seen the system, the infrastructure under that system, change quite a bit. And so this is the most recent sort of shift that we've made, is what remains useful as a service is called Terraform Enterprise. Now, this is a system that runs Packer and Terraform on your behalf, provides really nice VCS workflows for you to do pull request-based reviews, all sorts of nice functionality around the Terraform and the Packer workflow. We also extracted Vagrant Cloud within the past year to its own separate service once again. So as opposed to sort of baking it in with Atlas, now Vagrant Cloud is its own infrastructure. So that gave us the deprecating the console features, clarifying around Terraform Enterprise, gave us the clarity to allow us to start tightening the system for more efficient delivery. The other interesting angle, and this is one of the most interesting, is within the last year, we've also started offering Terraform Enterprise as both a SaaS and a private installation. And that creates all sorts of a single multi-tenant SaaS and a single tenant installation to distant LANs creates some really interesting infrastructure problems. So if you zoom out and you take a look at this history, so what do you see? You see a lot of work, a lot of releases, a lot of really excellent software, but also a lot of change, a lot of lessons, and a lot of iteration. And I think across two key pieces that I want to highlight, two key sort of themes. One is this kind of distinction between we are tool makers, and we know that the tools can be distributed as either downloadable software or as services, and us trying to figure that out, trying to figure out what functionality makes the most sense as a piece of downloadable software and what makes more sense as a service. And just us participating in the feedback loops about our software with our customers, with our users, with our open source communities, with ourselves. So you've heard me say over the course of this mini timeline several times where these are lessons that we've learned from our own operation of the software, from people using the software, and we change and we learn. Cool. So now, the moment you've all been waiting for. Here, I have on the next slide our infrastructure. We haven't talked about this publicly before. What does HashiCorp's own infrastructure look like inside? I bet you're wondering, and I have it for you right here on the next slide. Are you ready? Oh! Yeah, there it is. I bet you weren't expecting that. It's pretty exciting. I bet you've never even seen this anywhere. This is a novel infrastructure, and it's also very detailed, as you can see. Now all of this is true as of today. This is absolutely true. But half of it didn't exist when we started. And adding in these new technologies as they came out was a challenge for the infrastructure team that also had to deliver working software. We had to keep Atlas working even as we were introducing Nomad. And so you'll see that come in as we kind of dig into the more nitty-gritties. I think the other thing about this, I really love this view, but I think it can cause your eyes to gloss over a little bit. And so one of the things I want to show you is that the infrastructure that we're running at HashiCorp is very similar to the infrastructure that you're running in your shops. We're not doing anything special. I'll show you. Atlas, now Terraform Enterprise, is at its core, it's got a Rails app in it. When we started it, we kind of analyzed the Go web ecosystem and said, it's not ready. We had done a lot of pioneering in the Go tooling ecosystem. A lot of Mitchell H. and Armon libraries exist in the Go community because they were early into Golang. And we looked at the web ecosystem and said, we need to get a product out the door. So we had expertise in Rails. We knew Rails was a safe bet. And that's where the core of the web application that sits inside Terraform Enterprise is. Now that's served by a cluster of Go services, about a dozen of them. I'll actually put them all up on a slide in a second. And it stores its data in Postgres and S3 primarily. So nothing exciting there. And I think that's one of the things that's been so funny to me about people who want to hear about how HashiCorp does things. And it says, we have really great sort of marketing materials about the tools that we make and the way that we use them. But at the end of the day, we're not this church of perfect software, right? We are doing real work here. We have a group inside of HashiCorp that is using our software, but it's using it to do just a pretty standard web application. So if you take a look at the pipelines, so how do we actually get work done? They're also going to look really familiar. For our machine images, we store Packer configs in GitHub. We actually use Puppet to provision our images to install sort of the base level of software. This Puppet step was actually baking on the applications until Nomad came around. So we were doing sort of image-based rolling. And pretty straightforward. Nothing special. When we started, Terraform didn't exist. So we did start with CloudFormation. And it was interesting, until Terraform import was a thing, we actually had some old resources kind of hidden in the corner of the infrastructure that we began importing slowly by manually hand editing the JSON file of the Terraform state file. We said, this should probably be a feature. So we used Terraform, store it in GitHub, those configs, take those images, and launch them into instances. We, auto-scaling groups of instances are behind ELBs. I'm not even going to show you the sort of AWS diagram because it's that boring. You can picture it yourself. One of the things that's been really exciting about the private installations is it's forced us to be more transparent about our architecture. So there's it's a little bit low on the slide, but the Terraform Enterprise Modules repository is our deliverable for private Terraform Enterprise. So we just deliver Terraform config and share some machine images with your account. And in that repository is a bunch of documentation about the internals of Terraform Enterprise. And this is the whole thing. So it's not that huge of an application. This is a data flow diagram, so it's kind of focused on the way that data is pushed through the system. I'm not going to go through each of them individually. All the documentation is up online about sort of walking through each service and what it's responsible for. Generally speaking, what you see here is on the left-hand side, there's the Packer and Terraform build pipeline. Up in the middle, you have the web front end and the Rails core of the application. And then on the right-hand side, the part of the application that's responsible for ingressing from various VCS providers. One of the things, so there are two things I really like about this view. One, it's the one we use internally. So this is, I was considering making it prettier for the slides. And I was like, no, let's use the real one. This is represented as code. So plug for Mermaid. It's like a graph viz, but more like Markdown. So this is about 50 lines of text that generates this view. And it shows that this system is actively under development. So these on the right-hand side with the brackets are actually services we're in the process of changing out. So the bottom one we're actually done changing. The other one we're planning to change. So it's us learning the sort of microservices lesson of you over-factor your services, and you're like, actually, those three can probably just be one. They spend most of their time talking to each other. Maybe we don't need them to be so micro. So running this infrastructure, and again, that sort of relatively simple application is the sum total of what was once Vagrant Cloud, became Atlas, and is now tightening up as Terraform Enterprise. And so I like to spend the remainder of this talking about what it's like to run that infrastructure within HashiCorp. And that's where things get really interesting because of our positioning. Our team, HashiCorp, the operations team at HashiCorp, sits at the table right next to, well, we're a remote company, so it's not a physical table, but the digital table right next to the teams that are building these tools. And that gives us a really interesting ability to have some deep conversations about the way that the software works, the way that each of our tools is day-to-day. But we're not the only ones at that table. In fact, we have sort of an interesting positioning, but it is not terribly unique. The open source communities are still central to the way that the teams think about how to iterate on the software and make it better. And then our customers, our commercial relationships, give us insight as to how to make the products better. And I want to show you how that works, because I think this process is the process that everybody here is participating in right now and will continue to participate going out into the world beyond HashiConf. So let's take a look at an example or two. So this is something we said within the last year. We were saying console servers, we were having trouble automating around console server recycling. We said it's kind of tricky. You have to wait until the overall console cluster is okay before continuing on. And we were having to do a lot of kind of manual work when we were recycling our console servers that we didn't want to have to do. It was working fine, but it was a little bit more tedious than we wanted it to be. This is feedback that was consistent from the console team, from all three of these kind of subgroups. This is feedback that the GitHub community was saying, that our commercial partners were saying as well. And so console releases console autopilot. Just great bundle of features that are operator-focused, that make these kinds of operations that we're talking about much easier. And so this is an example of pure feedback and response, and it's great. We've had an extra special relationship with the Nomad team because we were earlier into the community. We had incentive to adopt it, and we have gotten really great features out of that collaboration. So including things like Nomad Plan. How do I know what happens when I execute Nomad Run? They came back with Nomad Plan, which is a great feature, great symmetry with our other tools. Template support. So we spent the first sort of iteration of our Nomad installation embedding the console template binary and one-shotting it ahead of our service run. So it'd be like console template, snag all the config, and then drop it on the local exec disk, and then go from there. Console pulls that in, we lose a whole step of our automation. Similarly, we have a deploy bot that we lovingly call Waffles. Waffles deploys our services day to day, and we designed that bot in concert with the Nomad team, such that when job deployments landed, it was using the same sort of mental model around deployments. So we haven't done this yet, but we can basically take Waffles and take 3/4 of it out and just change it into Nomad API calls. It's really great. And then, of course, the closest relationship we have is that with Terraform Enterprise itself. I don't want to tell you exactly when we broke the circular dependency. It is broken now between running Terraform Enterprise to manage Terraform Enterprise. It did exist for a time. We had workarounds where you could run Terraform locally under duress. But now we run an instance of private Terraform Enterprise for ourselves that manages the SaaS. And so, yeah, the feedback cycle here is very tight. We work with this team every day to make that product better. But here's my point. These three groups are valuable because they are distinct. And this is something that, if I could give you one thing to take away from 30 minutes hearing about HashiCorp operations, it's that the best practices that we're all searching for are being actively created by the entire community now together. And the best practices only come from all of us because we are different. All the time, I get asked, well, tell me exactly how HashiCorp operates because that's how I'm going to operate my shop. And I often have to respond, I can tell you how a high-growth startup operates. Like that's what HashiCorp, that's the sector we're in right now. The answers that I have for our teams, that our teams figure out for ourselves, are just not going to be the right answers. You saw that in the history. The narrative requires all of the characters involved in order to successfully evolve. So if you take a look at these sort of three groups, the GitHub community is the broad base. This is a bunch of practitioners. You get a lot of different kinds of use cases. People push the edge cases, and it's really great. The customer relationships traditionally for us have pushed scale. So they say, OK, that's great. I want to do that for 1,200 teams globally. And the metaphor that you've created for this particular feature doesn't make sense at that scale. And so, and our sort of operations team, the sort of unique flavor we're able to bring is the day in and day out. So we'll get that feedback from others too, but we can really give that peripheral vision to the teams, which is like, here's what it feels like, here's what it looks like for a team to be operating on these tools with these tools every day. And so not only do each of these groups distinctly are required to make the tools great, I think each of these groups communicating with each other is also where the best practices emerge. A lot of the way that we write Terraform config today we would not write that Terraform config today without our conversations that we've had with customers who are showing us how they're laying their modules out. And we're like, oh, that's a great idea. Our team's actually not that big for the benefit to matter, to split it up in that way. But that is a really great move, and we are going to move in that direction. So for instance, like the concrete there is that right now we still do generally one Terraform workspace for each environment. We're probably going to move to splitting that out into much more sort of a tiered approach. As our application gets bigger, as we get more people hanging out in the infrastructure. So on that note, I just want to give you a bunch of ideas that we're actively thinking about to show you that our team inside of HashiCorp is dealing with the same problems that you're dealing with day in and day out. One of the most common types of conversations that I have with people in the community is they say, hey, so like how would you solve this problem? This is something this is a friction that we're seeing with Nomad or with Vaults or with Terraform. And so often my answer has has the shape of, oh yeah, we have that too. It's really frustrating. We're working around it this way, but we're in a larger conversation on how to fix this. So this is just a bunch of just little examples to kind of get your brain active as you go back out into the community so that you can keep having these conversations, that the community will keep having these conversations. So right now, we are still in our Terraform config doing the sort of Terraform-based ASG blue-green, where you have two ASGs, if there's an ELB that they're behind, and you change numbers to deploy things. And this has been working perfectly fine, but it gets tedious, and it's stateful. It's sort of naturally stateful. And so we're really moving towards this concept of an unattended instance role that you've actually, I think, if you've asked around, there are people in this audience who have that implemented. We're focusing on our Nomad clients at first. So like one of our SREs is basically working on this actively this week, trying to figure out how we can get the notification of an instance coming down so that we can safely Nomad drain before the instance actually gets terminated. So that's something we're working on. We're very excited because it'll make sort of rolling every flavor of machine much more totally automatable. We don't even have to think about it. We don't actually manage we have two KV spaces in the Vault KV and Console KV that we don't manage with Terraform because the Terraform providers didn't exist when we first implemented them. So we have some pretty sweet Bash and JSON, we still manage them as code, but we manage them in this sort of like file system mirroring style. And so the key problem with these kinds of applications of Terraform is access. Terraform needs direct access to whatever API that it's going to drive. And from a Terraform enterprise perspective, you have a kind of single point of Terraform's execution. And so we're having all sorts of, there's a lot of different ways to slice this problem to try to figure out how do you execute Terraform close to the API? Do you try to tunnel the network in such that Terraform can talk to the Vault cluster? We have customers that have solutions for this. We haven't figured out which one we want to both use for ourselves and try to work with the teams to get better support for. But this is something that has a lot of active conversation about within HashiCorp. And so we're still on ELBs. You've heard me mention ELB several times. And it's one of those things that's been good enough that we haven't been motivated to make it better. We use console heavily for all of its other features. But for load balancing itself, we're just sort of living in the ELB world, which is fine. But we really want to get into something that's console aware for being able to more quickly shunt traffic around and not have to deal with the sort of clunkiness of ELBs changing traffic. And finally, this is one we're really excited about. So excited that we now sort of use this as a joke, as a solution to every problem. We're like, can we use Nomad Dispatch to just solve this problem? It's like, no, I'm just sick. Nomad Dispatch isn't going to do anything. But can we Nomad Dispatch some medicine? So Nomad Dispatch, if you haven't heard of it, it's sort of like the serverless primitive that works within Nomad. You can partially define a job, less a couple of inputs. So essentially, it enables you to do just-in-time execution of your workloads. And it really is like a transformative concept that really has the potential. So you saw RabbitMQ in the middle of our sort of build pipeline. We want to rethink that build pipeline in the context of Nomad Dispatch. Because what we're doing with the RabbitMQ right now is basically sort of naively scheduling work. And it's like, hey, check it out. We have a scheduler right here. So that's one of the things that's really exciting, I think, about adopting HashiCorp software is internally too, is it gives you these primitives that are just there to help you solve your problems. It's like, oh, console, we can actually really uniquely solve this problem with console or with Nomad or with Vault. So that's just a sampling of the things that we're thinking about. And so I've always wanted to give a talk where there's a question in the title, and then the answer is, it was inside of you all along. And I've done it. But I mean this. I do really mean this. You have all been doing this actively for the last 2 days, and I really hope that you continue to do this as you go back to your day jobs, continue to interact with the community, continue to interact with each other, and continue to make our tools better by sharing information, by providing feedback, and we'll keep listening, and we'll keep participating with you, and we'll make all of this continually better. Thank you.